So hello everyone, welcome to this Men&Mice webinar. My name is Peter Pettersson. Today's webinar is focused on PowerDNS. This is part 2, as we covered PowerDNS as well in an earlier webinar back in August. It is Carsten Strodman from the Men&Mice services team that is presenting here today. And please note that all attendees are on mute. However, we encourage you to submit your questions to the GoToMeeting control panel, and we will address these questions at the end of the webinar. We are also recording this session, and you can find the webinar along with the slides at our website within a few days. And at our website, you can also find recordings and slides from previous webinars. So if you drop off this call, there's no problem. Just you go to our website later on, and where you can enjoy the rest of it. So without further words, Carsten, the audience is yours.
Thank you, Peter. So hello, everybody. Welcome back to the second part of our PowerDNS webinar. And today we'll talk about some more advanced features of the PowerDNS authoritative server. So again, we will cover the recursive part, the PowerDNS recursor, in a different webinar, probably beginning of next year. So today I would like to talk about the web API that is there to remote control PowerDNS. I also will show how slave name servers running PowerDNS can be provisioned using what's called a Supermaster, and little tricks that can be done with scripting with the embedded Lua-Scripting language that is built in PowerDNS. And I will show some of the tools that come with PowerDNS, which can also be used independently from PowerDNS. So if you run any other DNS software, they might be still helpful. So first, the PowerDNS web API. So currently the web API is marked as experimental or work in progress. So it might change. So at the moment it works, but you can't really build on it that it will not change, like that the functions will not change. But still, it's quite useful already. It's a RESTful web API, meaning that you have certain URLs that map to the objects, like zones or resource records or server names in a PowerDNS installation that can be used. And the big benefit that I see from the web API is that it does extra validation. So every new data that you put into PowerDNS will then first go through the PowerDNS server itself, and there will be some extra sanity checking before it hits these backend storage, like the database. You can remote control and make changes to PowerDNS servers via the database backends today as well. But there's always the danger that some wrong data is being written to the database, and the database, of course, will take any data. It will not complain. But then PowerDNS might get a hiccup reading this data back in. And when you use the web API, there's less danger of that happening. So what can be done with the web API? You can create zones, delete zones. You can set the metadata on the zone. You can, of course, manage the resource records in the zone, like you can create, replace, and delete them. Configure the server's configuration and get statistics from either the server or the zone. There is plans to add access to the cache content. That is for the recursive part, and management of cryptographic keys like TSIG and the DNSSEC keys. There's already quite a lot of functions in the API, but there's also more that is planned for the future. So in the show notes for this webinar, we will have links to the full documentation, to the API documentation, and you can browse through and you see what's already been implemented and what is planned for the future. So use cases of using the APIs to automate server deployment and zone deployment via your own scripts, because this kind of RESTful HTTP APIs can be used from many scripting languages, Python, Ruby, Perl, etc. You can use that to integrate PowerDNS in your own customer portals. So if you are an ISP, or if you are an enterprise environment and you want to integrate the DNS server somehow in any existing portal application, you could do that. And of course, you can run your own user interface tools with maybe having special business logic attached to it. Now, I run a demo video that I have recorded earlier today about the Web API. So here I have a PowerDNS installation, and inside the configuration file, I've configured the default SOA fields. This is required if you want to create new zones from the API, and the Web API itself can be enabled in the configuration file, and there is an API key, which is like a password that's being used. From the command line, the API can be used with the curl scripting tool. We send the same secret key that we have in the configuration file, and on the right-hand side you see the RESTful API. Here we are asking for the list of zones. We pipe everything in the JQ command. JQ is a command line JSON tool that can pretty print and also filter through JSON output. And that is what you get from the Web API. You get the JSON objects back. And here's the list of all the zones, and I picked the last zone here, the Men&Mice.com zone, and I changed the URL to use the export function on the Men&Mice.com zone, and that will give me the content of that zone, like a zone transfer. Creating a new zone is done with a post command, and the data is also being sent as a JSON object. Here I'm creating the example.com zone, being a native zone, and the master servers are PDNS01 and PDNS02 example.com. We send the same secret key, and the URL is going towards the zones object, and it returns back the zone content, that is the NS record and the SOA record that has been created in it. That was all to create a zone. So now if I send a dig towards my name server, I can already query the SOA record and the NS records. And of course, I want to have more records in here, not just SOA and NS records. So I can do that with the Web API as well. And that is the patch command. Again, the data goes in as JSON, and it lists all the resource records that we want to add. Here, that's the change type replace, and the content is an A record with the IP address 192.0.2.80, and the name for that record is test.example.com. Record type is A. And that has been added. So back comes the JSON content of the zone, which now contains the A record. And if I do a dig for testexample.com, I will see that IP address being returned. And the last step is deleting a zone with the delete command. And the URL goes to the zones and then the name of the zone. And with delete, there's no data coming back, which means it's good. If there would be an error, we would having a JSON error description coming back. And if I now query for that example.com zone, I get a refuse because that zone does not exist anymore. So that was a small example demo of the API. And I covered the API first because I will use the API in my next example when I talk about the Supermaster feature. What is the Supermaster feature? It simplifies DNS replication and provisioning of remote machines. So first we have a look on the traditional DNS replication that you will find in other DNS server protocols, where we have a primary master on the right-hand side and one or more secondaries or slave server on the left-hand side. So with traditional DNS replication, the administrator logs into the master server, creates the master zone, adds then the master zone to the configuration and reloads the name server. And then the administrator repeats everything with the slaves. SSH logging, add slave zone to configuration, reload. Now, of course, if you have a nice tool like the Men&Mice suite, that will do everything for you in the background. But if you manage your DNS servers from the command line, that is the case, and you have to do all that manual configuration, which is cumbersome and error-prone. So after configuring the slave servers, they do a zone transfer request, and the master is sending the DNS zone data via zone transfer. And then all the secondaries are fully provisioned. Now, with PowerDNS, we can simplify this. All we need to do is to one time log into the secondary service to the slaves and add the master, that is the IP address and the name of the master server on the right-hand side, to the Supermaster database table. So this is a one-time task. And once we have done that, it's now possible to provision the slave servers without touching them manually. This is how it works. On the master, we still log in, we create a master zone and add the master zone to configuration and reload. The server, the PowerDNS server, as any DNS server product now, will look at the NS records in the zone and will send a notify to all the servers listed in the NS record set of that zone. Now, what's special now with the Supermaster setting is that all the secondaries will look for the notify and will check against the database whether the notify is coming from a Supermaster. And if it is exactly coming from a Supermaster, then they will, without any other configuration, start a zone transfer request. Basically, they create the zone themselves. Do a zone transfer request, zone transfer will be transferred, and the zone exists on the secondary. So in order for that to work, the secondaries must have the IP address of the master in the Supermaster table, which is a separate table in the PowerDNS database structure. Also, the master must be authoritative for the new zone, especially it must have a SOA record. Because after receiving a notify, a slave will check for the SOA record, will check for the start of for the serial number in the SOA record to figure out whether a zone transfer is required. And in order for that to work, the SOA record must exist on the master. And then there must be an NS record in the new domain that must include the name of the secondary and the master servers. And also these names must resolve to the correct IP address that is being used in the Supermaster table. So let's have a look at a demo how that all works. So here the master server is in the upper window and the secondary/slave server is in the lower window, so that we can observe what configuration changes have been done on the master and on the slave. So if we start at the slave, looking at the PowerDNS configuration file, and we see this machine is configured as a slave, and it allows notifies from our master. So I'm checking here with the web API the list of zones on the slave server, and it returns an empty list. So there are currently no zones configured at this slave server. Going here into the PowerDNS database, and there's currently no Supermaster configured. Now I'm insert the IP address and the name of the master into the Supermasters table. So the master is at 195, and it's called pdns01 example.com, and the account is the admin account. So now that data is in the table. That's all it needs. In order to visualize that the zone is being created, I'm now looking at the syslog of the slave server and changing back to the master on the top. Now we continue at the master, creating a new zone. Again, I'm doing that with the web API and creating a zone called supermaster.example. It's a master zone, and it has PDNS01 and PDNS02, which is our slave, as the NS records. Zone is being created. And now I need to send the notifies, and I can trigger that with the PDNS underscore control command. First, I'll look in the list of zones that the zone is in fact being created. And now I'm sending the notify. PDNS control notify and name of the zone. And that will instruct PowerDNS to look at the NS record set and send a notify to all the machines in the NS record set except itself if it's master. And we see now on the slave name server some log output that it has received a notify from the supermaster, created a new slave zone, checked the SOA record, and then did a zone transfer. And if we now look at the list of zones, we see that there is a new slave zone being created on the secondary. And of course, we can dig this zone, the 197, that is the IP address of our slave server, asking for supermaster example NS record set, and the data is there. So that was the supermaster function. And now we have a look at some Lua scripting. Now, what exactly is Lua? It's a small and fast scripting language which is very well for embedding, that is, putting the scripting language within other programs. Work on Lua has started in 1993 in Brazil at the Computer Graphics Technology Group, and it's a multi-paradigm programming language. It's quite easy to learn. Multi-paradigm means that it's neither fully object-oriented only, it's not fully functional, it takes the best parts of other languages. So if you want to do some like simple iterative programming, if you want to do some object-oriented programming, or if you want to do some functional programming, that's all possible in Lua. And it's executed as a bytecode in what's called a register virtual machine, which makes it very fast. So it's not that the scripts are being interpreted every time they are running. The scripts are being compiled into bytecode when the script is loaded. And in case of PowerDNS, that is when the PowerDNS server starts up, and then the bytecode is executed, which is quite fast. Not as fast as compiled assembly code, but in most cases fast enough. Lua is very popular in the gaming industry. It's used as a scripting engine in many popular games, but it has also users outside the gaming industry. And we have here a list of, it's not a complete list, but some notable software tools that are using Lua, like the Cisco ASA firewall. There is a version of the TeX layout language called Lua-Tech, which can be scripted with Lua. The media wiki, which runs Wikipedia, is partly based on Lua. Very interesting, there is a Lua module for the NetBSD kernel, where you can then write kernel device drivers in Lua. I personally use the Prosody Java server, which is nice. And there are other tools, like you see here, won't list them all. And there's PowerDNS that also has Lua. So what can we do with PowerDNS and Lua? Well, there is a Lua backend, which can be used to provide DNS answers directly from a script. The amount of use cases is indefinite. You can do almost everything there, but some ideas here, what you can do is, for example, for IPv6, creating PTR records. For IPv6, it doesn't make sense to pre-populate reverse zones like some people do for IPv4. But instead, it's not possible because there are so many IPv6 addresses in a subnet. There's no machine, no database server, no DNS server that can load a zone with that many IPv6 addresses that are in a subnet. So what you can do here is create the PTR records on the fly, have the Lua script look up the host names and send them out. And if there are no fixed host names, create one on the fly. It's possible to create your own backend systems with Lua. So if you have some strange database system where you have DNS data in, and you want to use PowerDNS to serve that data, you can use Lua as the glue language between PowerDNS and your database. And I've seen people using the Lua backend to create on the fly special resource records like TLSA or OpenPGP key that is fetching the keys for an OpenPGP key from a keyring, using that to create SMIME certificate records and so on. Now we have a demo on Lua scripting. And in this example, using the example script that is provided with PowerDNS. So the script is in the PowerDNS directory, var-db PowerDNS, and it launches the Lua backend in addition to the MySQL backend. So the script is in var-db PowerDNS script.lua. We will have a peek into that script in a moment. Opening that with Emacs, and this is the Lua script. It has some zone data in some data structures, some tables. Here we see the NS records for test.com and the IPv4 and IPv6 addresses for NS1 test.com. And this is a typical function in a Lua system where a lookup is coming in for a query type, query name, and the domain ID, and then we can send out the data. And I'm removing the command, which is the double minus, which is the way how you command out stuff. So I'm enabled logging in the script so that we see what's going on. Restarting PowerDNS, and in the log output we already see that PowerDNS Lua backend is starting up. Now I'm sending a query for test.com, and this SOA record has been returned from the Lua script. So there's no zone file or some database data that is serving test.com. It's coming directly from the script. Now I'm asking here for the NS records, and I'm getting a server fail. Why? No, there's a typo in the script. I've made a typo typing in an IPv6 address, and the log output tells me that there's a parsing problem. There's a double colon missing. So I'm going back into the editor and fixing that problem with that IPv6 address. Saving the script again and then restarting PowerDNS should fix it. So PowerDNS is restarted, and now I do the dig again, and now everything parses just fine. And we see here the NS records plus the IPv4 and IPv6 addresses of the name servers. And in the log output, we see the request coming in from the same machine as the local machine, the 195, the port number, and you see the IP address of the PowerDNS server where the query is being received. So that was a small example on how to use Lua as a backend. There's more Lua in PowerDNS, which is in the zone transfer filter. So you can write a filter for incoming zone transfers on the slave server. Basically, the Lua script is called after the zone transfer, and it has access to the whole resource record in all the resource records in the zone. And it can make changes to that before the data is being given to the secondary server and being stored in the database. And use cases here would be to add special, maybe informational resource records into the zone and have them different between the secondary servers. Or you can maybe fix the serial number if you have a product, maybe that is the master is maybe not PowerDNS and is a tool that just works with sequential serial numbers, but you want to have date formatted serial numbers. You can do that here. Or you can just read the changes and store them in a version control system to have an audit trail of all the changes that have been done to the zone file. So it's the possibilities here are endless. And last but not least, some of the tools that come with PowerDNS. So there are some nice tools that are part of the PowerDNS distribution, and they are independent of the PowerDNS server itself, so they can be used with other products as well. For first, there is the DNS dist, which is a DNS load balancer, and that is currently being transformed into a separate product. It has been part of the PowerDNS distribution for a longer time, but it accumulates good features, so it wants to be a separate, its own product. And you can find information on the dnsdist.org website. It's currently under heavy development, and it will get more features over the next foreseeable future. There are some tools to analyze DNS traffic, like DNS Washer, DNS Scope, Scan, and Replay. And I will show a demo of these. And there are benchmark tools like DNS Bulk Test that you can use to test a recursive server, a DNS Replay, and DNS TCP bench that can be used to benchmark both recursive and authoritative server. And there are some troubleshooting tools like the NSEC3 dig and the SAXFR, both which I will also show in my demo. So here a short demo of some of the tools, not all of them. And we start with the SAXFR. First, I do a traditional zone transfer with the dig tool. And I'm doing a zone transfer from nsec3.dnsec.works, which is a zone signed with nsec3. And looking through the data that you get back from a zone transfer with an nsec3 zones, it's very hard to see the real problems here because there's so much cryptographic data which is nonsense for humans, but it's only useful for computers and machines. So with the AXFR tool, we can do a zone transfer, and the tool will strip out all the cryptographic stuff and replace that with some placeholders. Like here in the signatures, we see the expiry, inception, and key tag fields, but not the actual data. And also we don't see the key and or signature blob. Same as with the DNSSEC keys. We see the key signing key and zone signing key. We see the algorithm here, but not the key data itself. So that is already helpful for doing some troubleshooting. Next, some tools that work on PCAP files. PCAP is a standard format for capturing network traffic. And tools like Wireshark or TCP dump work with these files. And here I have a file, a small capture with DNS data in there. And the DNS scope tool will look through the PCAP file and give me a statistical breakdown of what's in the file. So how many queries, how many IPv4 queries, how many IPv6, and also if there are queries and answers in the file. So if it is a trace from like the network just in front of a name server, you can have the answer numbers and the histogram there. The DNS scan tool also goes on a PCAP file and prints out the list of resource record types being found in that file. Now, it is a rough tool in the way that it doesn't translate the numbers into the meaningful mnemonics. So you have to go like to the IANA.org website and figure out that number 15 is actually the MX record, and number 16 is the log record, or 29 is log, sorry, and 28 is the quad A record. But still, it's a helpful small tool. So the next tool is the DNS washer. And in order to show what it does, I'm first using TCP dump to read the PCAP file and print it out. So in the PCAP file, we have IP addresses, which in some countries are personal data. So you have to be very careful what to do with these kind of files and how to share them maybe with some researchers. What the DNS washer does, it replaces all the IP addresses in a PCAP file with anonymized IP addresses. So the content is still there, and every IP address is mapped to the same IP address again, just the counted number. So we see here that now the IP address is translated into 0.0.0.1 instead having the original IP address. So DNS washer, it takes one PCAP file, reads that in, and writes out a new PCAP file with all the IP addresses anonymized. And DNS replay now works on a PCAP file and can replay the queries that are in a PCAP file. So if you have a trace of a name server and you want, for troubleshooting reasons, just try it out again, maybe try it out against a different name server, you can do that with DNS replay. It either does the replay in real time, that is in the same speed that the original trace has been done, or it can do that as fast as possible. And you can also have the speed in between. And then it gives at the end some statistics on how the original run, the original trace, compares with the run that you just did. So if there is a difference in successful answers, maybe a difference in failures, and you get a histogram of the speed of the answers. So it's possible there to compare from a set of queries in the PCAP file the relative performance of a name server. So the first run that we have seen was against a local DNS server, a local resolver, and the second one was against the Google public DNS. We had different data there. And the last tool that I'm showing here is the NSEC3 dig, which is a tool to query especially NSEC3 negative authenticated denial of existence data. And here I'm asking for xyz.www.nsec3dnssec.works, a record, a domain name that doesn't exist in the nsec3 dnssec.works zone. I'm sending that against the .22 IP address port 53, and I'm setting the recursion desired bit, so to trigger a full recursion. And this now spits out a lot of data. It gives me the original reply coming from the name server with all the NSEC records and the signatures in there. And then it creates a report on what actually is being proven by all the NSEC records in the answer. And that's actually fascinating, and it's a great tool to help to learn how NSEC actually works, what it does, and how it is being used to authenticate non-existing data, and also to correctly prove that certain wildcards don't exist in the zone. So this was the small demo of the tools coming with PowerDNS. And that concludes the content data of the second part of our PowerDNS webinar here. Let me give you some hints on, or some information on our upcoming trainings here. We have a bind training coming in end of September in Arlington, which is already confirmed. We have a few seats left, so if you want to join there, it's still possible. It's either the 2-day introduction DNS and bind, or it's the full 5-day advanced DNS and bind, including the introduction. And that goes into DNSSEC. We have dynamic updates in there, views, some chapters on DNS design, like hidden primaries and such. Then we have some trainings coming up in Germany. We have a DHCP workshop in the Linux Hotel in Essen, and then in the end of October, our DNS and bind training, which is the same training that you have in the US, but this is in German language, and it's also already confirmed. In our upcoming webinars, the next webinar will be on the 22nd of October, and there I will talk about keeping DNS servers up and running with the Runit tool, which is a supervisor tool that you can use with any server type software on Unix to automatically start and stop it. And it's like a replacement for start scripts. It does a little bit what systemd does, but it does only a sane part of it. And it doesn't come with all the baggage that systemd brings. Then in November, we will have the report on the RIPE 71 meeting and the ITF meeting in Yokohama. In December, we talk about DNSTAP, which is a new facility to have a deep look into a DNS server without the performance penalty that query logging has. We show that in Unbound and Knot DNS, and just learned last week that DNSTAP is currently being implemented in the bind name server itself, and maybe by December we might be able to also show how DNSTAP works in bind, but I cannot promise that. And then next year we'll have a look into the new DNS server coming from Microsoft, the Windows 2016 DNS server, which is a big leap forward. Microsoft is announcing new features for that product almost every week now. Great blog posts there, and we'll have a look what's new there. And then later next year, maybe February, we will have an update on DNSSEC and DANE, what has changed, new stuff from the ITF, and about market adoption. So, do we have any questions, Peter?
Yes, indeed, Karsten, and thank you. It was very enlightening, and I'm quite impressed with all the tools and features you demoed there. Now, we have a question from David here. You see, with Supermaster, only the slaves have to be PowerDNS, and the master can be any server type. Is that right?
Yes, I haven't tested it, but from how I understand the Supermaster feature, yes, it's because it's regular notify and it's just regular DNS, and the slaves are configured with the Supermaster table to receive the notify from the Supermaster and then configure it. And Peter van Dijk, who is one of the PowerDNS developers and on this webinar, just confirms that yes, it's right. You can have like a bind server or Microsoft DNS or NSD, anything that can send RFC compliance notifies can be the master.
Very good. So, Karsten, I have no further questions for you from the audience. Anything else you need to communicate at this point?
There are new bind versions out just yesterday, 9.10.3 and 9.9.8, with some nice new features. We at Men&Mice have binary installation packages for people who want that, for Red Hat-based Linux system, for Debian and Ubuntu and Solaris, and also will build macOS versions shortly, probably over the weekend. There are some nice new features in the new bind versions, so if you run bind, have a look at the release notes. You can find them on the IC website.
Very good, Karsten. So thanks again for great coverage of PowerDNS. And for everyone on the call, this was recorded, and the webinar will be accessible through our website along with the slides within a few days. So thank you all for attending, and Karsten, thank you as well.
Thank you all. Have a good day. See you next time.
Yep, bye-bye.